Hello once again. Trying to explain now, I was asked about horsepower and torque. There is a definite relationship between horsepower and torque. Now, does horsepower come from torque or does torque come from horsepower? It's like saying, did the chicken come first or the egg come first? No. Let's understand horsepower. Years and years ago, when we talk about engines, we talk about horsepower, right? Obviously. Hundreds of years ago, we didn't have automotive. What do we have? We had horses doing the work for us, right? Pulling weights, pulling loads, pulling carriages. Thus, you can understand where we get the terminology of horsepower. Okay? Now, in this pictorial over here that I picked out over here, horsepower and torque. A horse is here, obviously, in the pictorial. There is a job to be done. This horse is pulling a weight, a load on it. The load that he's pulling weighs 200 pounds. He's gonna walk 165 feet to pull this weight up 165 feet. So he's walking 165 feet to accomplish this, weight to go up 165 feet. So one thing is obvious. The more horses that I'm going to put, right, to accomplish this, if let's say instead of one horse, it's going to take two horses to accomplish the same feat, I don't want that. That means it's only half power is being accomplished. But the more horse, if you want speed, if you want this object to move, let's say I want to move an object from A to B, okay, in 1 second. Let's say, well, actually, let's make it 5 seconds. Let's make it 5 seconds. One horse will pull it a certain amount of time. If I add another horse, what will happen? I will move this object quicker. If I add 3 horses, what will happen? It'll move it even quicker. The more horsepower I add, the quicker the object will be moved a certain distance, and obviously the car will move quicker. Horsepower. Torque. Where's torque? Torque is this twisting force on an object. For example, let's say I have a jar, a container or a jar with a cover on it that I have to open. Okay? Let's say that jar of mayonnaise or whatever is closed. I try to open up that cover, that cap. The first time that I do it, because it's so tight, I have to put a lot of torque into it, a lot of twisting force on it. But the second time that it's already open, guess what? I don't have to put too much force on it. Why? Because it's already open. So less torque, less force on that container. How does this apply to what we're talking about? Am I going off subject? The wheels of the car need a certain torque. The drive shaft, everything needs a certain torque, a twisting force on the wheels, on the axle, on the drive shaft to make sure that those wheels turn. When do I need horsepower? When do I need torque? From this example, we have torque. Okay, as you can see here from the formula, the length and the width. So 160 feet it took for him to pull up 200 pounds. This is in foot-pounds. This equals a torque of 33,000 foot-pounds. That's torque. When we know the torque, we can figure out horsepower. So you see from here, if we know the torque of the engine, we can figure out the horsepower of the engine. The more torque, the more horsepower output, right? So therefore, as we said before, I'm pulling this automotive. When do I need horsepower? If you want speed, if you want to get an object from one location point to another one, you're going to want horsepower. Why? Because you want to get it there faster. Torque. Okay? Now, torque, let's say F-150 or has like 400 foot-pounds of torque or even more. When do you need that? When you're pulling loads, you're worried about things like that, about torque. Okay, let's say in Texas, the farmers, they love these pickup trucks. Why? Because they're constantly doing farmer work, agriculture, obviously. They're pulling loads. They're filling up that pickup truck, the F-150 or whatever they're doing, the Silverado, whatever they're using, they need a lot of torque to move that object, a lot of weight on the back of that car. The express vans that we use today, a lot of construction workers use it, a lot of fleet trucks use it, a lot of police use it. There's weight on it, so it's doing a job. It needs torque. Okay, now let's say the Jeep Wrangler, when you're going off-road, you need torque because you need the wheels to get a lot of force on it. You're not worried about speed. I'm not worrying about, if I'm a farmer, I'm not worrying about going 100 miles an hour. I'm worried about pulling all that load that I have in the back of that pickup truck. Okay? Now, as we said before, torque is also important. First, in the automotive, when you have an automatic or a manual transmission, what gear are you in first? You're always in first gear. That first gear is always the highest gear ratio, the torque. It could be 2.1 to 1 or 2.3 to 1, but in first gear you always start with the highest gear ratio, you need torque. What does that mean? My car is parked. Here's my car. My car is parked. Okay? It is parked. It is stationary. It is harder to move this car when it is stationary than when it starts moving. Let's go for an example. Here's a table. Me and you are moving this table. When is it hardest to move this table? When it is stationary. So we move this table. You're on one side, I'm on the other side. You're pushing and I'm pushing. It is hard to move it. But guess what? Once we're moving, what happens? It's easier to push it or pull the table. Why? Because it's already in motion. Inertia. Centrifugal force. It's already being moved. So we went from first gear, which is the hardest one, to second gear, which is less gear ratio, to third, which is less gear ratio. In the beginning, it's always the hardest because it's in a stationary position. So is the automotive, the car. When it is parked, it is harder to move it. But once that car is moving out of that parking space, we don't need that much torque. As it is cruising on the highway, we don't need that much torque. We need speed, right? So that gear ratio will decrease over that. That's how horsepower is rated, and that's how it is very important to understand the difference. So I hope this helped. Now another point: if you have, let's say, 2 pistons, 4 pistons, right? Let's say that in this graph over here, this is 2 pistons in that engine. This is 4 pistons, 4-cylinder. 2-cylinder, 4-cylinder. Look at the torque. With engine RPM, as it goes up, this one, torque goes down. The more cylinders you have, the more torque you have. So what can we derive from this? If I'll have a 6-cylinder, I'll have more torque output from that engine. If I have an 8-cylinder, I'll have more torque. But the torque will not always stay level as the horsepower comes out, because there is a level where, you know what? It bottoms out. It cannot always go constant. It cannot peak. It has to drop after a certain point. So this is just a quick explanation of horsepower. Remember, horsepower. If you want a Bugatti or you want a quick car, a 12-cylinder car, of course you're gonna look for speed. If I want to go on off roads, you're going to look for a Jeep Wrangler. Just look at those tires that tread on those Jeep Wranglers, and you know it's for off-road. They're going up those hills and those mountains and all that. So that it depends what your need is. So anyway, please go to my channel, Joe Electronic Schematics for Auto. And remember, there's different kinds of horsepower. As you see over here, there's brake horsepower. There's net horsepower. You lose horsepower from the engine to the wheels. Okay, so remember that. There's all kinds of horsepower, also friction horsepower, gross horsepower. Not going to get too technical about all these terminologies, but remember, the more torque, the more horsepower you will have. So again, please go to my channel, Joe Electronic Schematics for Auto. You'll have more videos, and you'll see videos about how to test an alternator and how to test sensors and things like that, how to test batteries, which is very, very important. Thanks for watching.